Let us see how to remove the background of this image, which you can use it for your own photos instead of using paid tools from internet. Now, import the necessary libraries. One is our EMBG to remove the background, the other one is PIL library used for opening, manipulating, and saving many different image file formats. Now, it is time to read the input file. Let us assign input file, say abc.jpg to input image variable and also assign a file name for output image to output_img variable. We need to load or open the image first, and for that we can use image method from PIL library and we give the input file name. And we need to use remove method from the REMBG library, where we can pass the above image and capture the output here. So now, it's time to save this output image. So for that, we have to call save method for the output. And we are passing the variable output_img which contains the file name which we want to save. I have written couple of print messages to inform the user about the progress. Let us execute it now. So we have to wait a couple of seconds for execution. You can see the message now that the background is removed and the image has been saved. Let us open the file. See, the background was removed. It did pretty good job. As a note, the file will be saved at the same location of the Python file, which can be changed as per your need. Let us start with second one. This program can be used to generate random data. As an example, you can use as in dummy data for application or reports, or also for some kind of data engineering projects. Let us start doing that. We need to import Faker library to generate random data. And also we use a pretty table package to output this data in a table format in the console. Let us initialize a variable fake with Faker class. Now, it is time to create a method called generateFakeData. And it takes one input parameter called number_entries and which has a default value of 10. And now let's take an empty list and assign it to a data variable, which can be used to store the generated data. As an example, we will generate employee data. Now, we generate data one by one. For that we will go through a loop of number_entries. In this case, it will be 10 by default. In this loop, we will generate data for multiple fields. For example, name, job, date of birth, etc. So, let us declare an empty JSON object which hold this info. And the first field will be employee ID, which can be random number from 1 to 100. So, we import random library. And we write employee ID :random.randint and give 1 and 100. This is just a random integer. Now comes the actual use of Faker library. Let us say name. And for that we write fake.name. And similarly for city, email and phone number. We also want to generate date of birth. So for that, we have a date of birth method in Faker. We can give minimum age and maximum age and also in which format we want the date of birth to be. And also generate, for example, job title, company, a random description about that person. So these are the different properties we are trying to generate, and it's generated as a single object. And now let's try to add this object into the data list using append. Once the data is generated 10 times, we'll return this data. Now let's call this method from main function. So in the main, we are passing number of entries as 10 and also can adjust number of entries. The data is which is returned from the method will be assigned to fake_data. We can already print this data in the console. But as to explore another library and also to see the output in a proper format, we use pretty table library. And for that we'll initialize the pretty table. And has a field name property to add the columns headers. and which can be as per the data. So these are the different kind of fields I want to display. Now let's add the data to the table. For that, we need to loop through the data and add row by row to the table using add_row method. So, we'll add all the fields from the list and we'll try to print the table. Let us execute it now. You can see it generated random employee IDs, name, city, and also an email, phone number, different kinds of phone number and date of birth and job titles, company, and some random description about that person. So this is pretty good, right? So this is how this pseudo data can be generated. Let us write a program which can convert text into audio. Let's take some PDF file with 2 pages and convert this text from PDF to an audio. For that we can import 2 libraries. One is to open the PDF and read it, and the other one is to convert this text into an audio. We have PyPDF2 that can be used to read the PDF, and the other one is for PyTTSX3 to convert into audio. We have an PDF reader method which can open the PDF file, and we will assign this file to PDF reader variable. Next step, we'll initialize the other library with the init method and we'll assign it to a speaker variable. We need to read this entire text from the PDF and store it in a text variable. So that's the reason we have declared one more variable. Now it's time to use a loop to go through all the pages one by one. So we will read page by page. So that's the reason we have used a length function to see how many pages are there, and we loop through it and try to read the PDF. So we are using the variable PDF reader.pages, and we can pass the page number, for example the first page, which is index 0. So it passes 0 and extract_text method will extract the text. And we will try to clean the text little bit. We will strip the text and replace the new line with empty space. We are also printing the information to user. We will append this clean text to the output text variable. So, the loop executes for all the pages in the PDF and capture the text from the PDF to output text. So, once we have this output text which is from the PDF, we'll try to start the conversion to audio. For that we'll use this initialized variable speaker and we'll save it to a file. As you know, you need to save it to a file after conversion. So we need to pass this text and the file name basically. Now the speaker is ready to do that, but we need to start this process. For that we have method run and wait from the speaker. This is where the speaker tries to convert the text into an audio. This line will take some time for conversion. So, before you start converting another text, it will wait until this line is executed. But we have only one variable with complete text. After it is done, we can also print a message to the user that the conversion is completed. After that, we'll stop the speaker. So, once all the text is converted, we need to stop it. This is how you can take a text and convert into an audio and print it out. Let us execute the program and you can see it prints the message and generate an audio file. So now, let's try to find this file. Say for example it will be here at the same location of Python file, and I'll open this file from the Explorer. Let us play this file.
Once upon a time, in the heart of a dense forest nestled between towering mountains, there existed a quaint village named Willowbrook. Willowbrook was
This is how we can convert text to audio. You can explore this more and generate your own audios for the blogs or textbooks, etc. Let us now build a NATO encoder. It's a tutorial for encryption where we will encode a message into certain words and decode the message to proper word. We use Streamlit for UI design. So, we import Streamlit library, which will be used to design UI with tabs, an input box to enter message, and a button, which calls functions either to encode or decode message. And then let us create a dictionary object which hold all the keywords to encode. I have copied it and you can see all the characters having another name, for example A for beta, B as gamma and C for cipher, like that. We have written all the alphabets and also space has space word. Now let's write two different methods. One will be to encode the message and the other will be to decode it. Let's now define the function called encrypt message, which will take message and NATO encoder object as input parameter. We will declare a variable called encrypted message to store the message which will be encrypted in next steps. Let's write a loop to loop through each character of the message. And check if the character is present in the dictionary. For that, we will write a if condition and check the convert the char in uppercase and check if it is present in NATO encoder. If yes, we will add the value of this character to encrypted message with a space. For example, if the first character is B, we will get the value of B from NATO encoder, which is gamma. So the encrypted message will have gamma plus space. The next one, if it is Z, then it will be theta. Now if the character is space, then what is the space? For the space, we get the space value. If the message has some other character, then we write else and then we'll just directly add those character directly to the encrypted message without any encryption. So, in this loop, we will take each character from the message and encrypt it. And then, we will return the encrypted message. So this will be the encrypt message method which takes a message and encrypt it. Similarly, we can decrypt the message. And for that, we need to write a decode message method. We declare a variable to capture the decoded message. And here, we need to split the words because the decoded message will be with these words, so we need to split. And now, we have to go through these words as loop. So, here we take word by word and decode it. And also we'll take another loop to go through this NATO encoder. Here you can observe, we are taking key and value. And if this word is matched with one of the value of this NATO encoder, then we will take the key. This will be the key and this will be the value. So if we have kappa in the message and if the kappa matches, we'll take the character K and add it to decoded message. Whenever the value is matched, we'll break the loop. And if there is no value matched and loop executed completely. Because there could be some symbols like which we don't have any symbol in the NATO encoders here. So for that purpose, we write an else for this loop, where if the loop is executed completely we directly take that specific word and add it to decode message. So you can see this assignment plus and equal to. That means the converted characters are being added. After that we'll return this decoded message. So we have two methods, one is for encrypt and one is for decrypt. Now let's design the UI screen using Streamlit. So let's define a main method, and as we will use st because we have imported Streamlit and gave an alias as st. We can write st title to give an title to the screen. And in the left-hand side, we can have a sidebar and we can give two radio buttons. And which will have a text as select tab and the value for radio button to be encode and decode. So, there will be two options in the screen. So if the tab choice is encode, then we'll set a header called encode message and we should have input text box to enter the message to encode. So we will use text underscore input and also, we will have a button. When this button encode is pressed, the encrypt message method will be called and the encoded message will be successfully shown in the bottom as an output. We have used success as we want to see the text with background green color. Similarly, if the tab choice is decode, we'll also set some header and also take the decode message as the input. And there's a decode button which will call decode message method and then message will be decoded. We will successfully print the message. We'll call this main function at the bottom. So this is how you write it. As we are using Streamlit library, you may not execute using the play button. So, we have to execute it from terminal. Execute it using Streamlit run and mention the path of the file. We can use this local URL to open the application in browser. If you see in the left-hand side, we have two radio buttons. One is for encode and another is for decode. If you select encode, you can see encode message screen and a text box and encode button. Similarly, if it is decode button, you will have this. OK. Now, if I give a message, say Web Wonders in the input box, I got this message as omega, zeta, gamma, etc., which is an encoded message. So now I'll just copy this message and go to decode. You can see it decodes correctly. This is how you can do simple encryption and also use Streamlit library for UI. In this program, let us take an image and convert it into a pencil sketch. I hope this is an interesting topic you would like to learn. So for that we need to import a library. You can use CV2, but when you want to download it, you should install it with OpenCV Python library. You can install using pip or from the packages directly. Let us read the image. And for that, we need to use imread from CV2. Imread means image read. Let us give the file name. So, this is the image we want convert into a sketch. So after reading the image, for example, if there is no image with this name, then it prints an error saying image not found and we exit the program. There are different steps to convert this image into a sketch. For that, we have to convert the original image to a grayscale. So, from CV2 we have CVT color. And we pass the image and also give the input color underscore BGR2 gray. So, the image was converted to grayscale. Once it is gray, we have to invert this. For that purpose we have to subtract the gray image with 255. The value 255 is commonly used for white pixels, and subtracting it from the pixel values effectively performs a color inversion. After we take this invert image and apply Gaussian blur, and for that we have a method called Gaussian blur. By applying Gaussian blur to the inverted grayscale image, noise and small details in the image are smoothed out, resulting in a more uniform and softened appearance. This step helps in producing a smoother and more aesthetically pleasing pencil sketch effect in the final output. So we have got a blurred inverted gray image. Now, we should invert this image as well. For that, we will use the same technique as above. We will subtract the blurred inverted gray image with 255. Once we have inverted blur image, which is a Gaussian blur, we use divide method from CV2. This method is used to combine two images in a specific manner to produce the final pencil sketch. We have input the gray image and an inverted blurred image. And with the scale 256, which effectively controls the intensity of the sketch effect. Okay, now let's try to print the original image with a title, original image, and pass the image and also the sketch image as a second window. So, two windows will be opened, one with the original, one with the sketch image. Once the windows are opened, if you press any key in the keyboard it closes all the windows. Okay, let's run and see what's the output here. You can see here this image was converted to a pencil sketch with a Python code. It looks pretty good, right? And now, if I press any key and both the windows will be closed.